All right, ran out a little bit of time because I'm only capped at 15 minutes. So let's keep talking about this problem. So we were talking about the y-intercept, and that's when x is 0. So if I put 0 in for those x's, the original problem, that is, every term is just going to turn into 0. And so when I'm adding and subtracting with all zeros, my intercept, y-intercept, when x is 0, just gives me a y value of 0, which I already have. And now I'm ready to make my shape. So on the left, it's going up. On the right, it's going up. And now I'm going to make a new set of arrows. I'm going to get here, cross, turn to get to here, bounce off, and then cross through. And again, my arrows match up. So that is the rest of page 2. We can start page 3. So now we're going into solving all the different ways to solve. So I will probably have to make 2 videos for this page, but that's okay. All right, let's start with our absolute value problem. So let's just do all the absolute value problems first to get that kind of stuck in our head. So it doesn't matter what we're working with. Our goal, because it's one type of x, will be to get x by itself. So even down here on 25, x by itself. So in the first problem, I'm going to move the 4 by adding 4. So that leaves me with the 2 over here. And then on the other side, I'm going to divide by 2, don't distribute. Absolute value bars are not parentheses. So over here, 2 divided by 2 leaves me with a 1. And now we're going to have 2 problems. One is going to be x plus 3 with a positive 1, and then x plus 3 with a negative 1. In both situations, I'm going to subtract 3, but I'm going to get very different answers. So on the left one, I'm going to get a negative 2, and on the right one, well, let's put it up here, I'm going to get a negative 4. All right, that's 16. All right, finishing the absolute value. So 17, we're going to isolate the bars again. So just a reminder, not touching these. So first I'm going to subtract the 2 over. Which leaves me negative 6 on this side. And then I'm going to divide by negative 3, which leaves me with a positive 2. And now, just like before, I can make 2 problems. One with x minus 5 equaling 2, one with x minus 5 equaling negative 2. In the first situation, I'll add 5 over for 7, and in the other one, I'll add 5 over, but this time I'll get a positive 3. All right, last absolute value. So I'm going to jump down here. This time it's an inequality, but again, I'm just going to isolate these bars. So the first thing I'm going to do is add 6 to the other side, which leaves me with 8, and then I make 2 problems. At this point, I'm going to drop the inequality sign. And in the first problem, I'm going to subtract the 5 over, so I'm going to get 3. And then the next one, when I subtract 5 over, I'm going to get negative 13. This problem has an alligator, though. So I'm going to remember that this is a regular v. There is nothing to flip it. And then I have a meeting at a line of 2, and I've got negative 13 over here and 3 over here. So this says that my alligator would be happier, greater than, or above the 2, the flat line that is. So here and here. And on the left, arrows to the left are negative infinity. On the right side, they're infinity. So when I write my answer, I will expect it in interval notation, negative infinity to negative 13, parentheses on both because the inequality is not underlined, and then again from 3 to infinity. All right, those are all the absolute value problems. So, oh, nope, I take it back. There's still 26. Let's do 26. I didn't notice it. So here, to get rid of the fraction, because I want to isolate the bars, to get rid of a fraction, you can actually just multiply it by its reciprocal, because this numerator takes out that denominator. So we're actually just left with the absolute value of 4x. And then on the other side, I'm left with 4. So now I can set this equal to 4. And negative 4, and once I divide by 4, I get 1, and -1. So again, we have a v, a regular v. We have a flat line that it intersects with of 2, meaning at -1 and 1. And again, we have another inequality sign, so we're going to see where the alligator's happy. And this says greater than or equal to, so again, there's another above situation. Arrow on the left is -infinity, arrow on the right is infinity, so my answer is from -infinity to -1, and from 1 to infinity. But this time my numbers are going to have brackets around them because the inequality is underlined. All right, that takes care of all the absolute values. Let's move on to, how about if there's one type of x after that? Okay, so let's look at our squared problems, actually. Let's do that instead. So on the squared problem, yeah, let's go ahead and do this one. Another alligator problem, but it's one type of x, so I can just get x alone. So I'm going to subtract 1, which leaves me with 16. And then I'm going to square root both sides. And it's on this square root step that I get two answers. I get 4 and I get -4. So I really have two problems, x minus 2 with 4, x minus 2 with -4. I'm going to ignore the alligator for now. I'm going to add 2, which gives me 6. And then I'm going to add 2 again, which gives me a -2. So I shouldn't be underlining these. Let's see if we can get the circling these. All right, so we have a U shape. It is not flipped. We have another flat line of 17, no slope. Here is -2. Here is 6. And again, it's greater than. So just we're looking for above the flat line. So here and here. So there's -infinity, there's infinity. So when I go for my answer, the alligator will be happy from -infinity to -2, parentheses, and from 6 to infinity, in parentheses, because again, the inequality is not underlined. Let's go for our next squared. So our next squared problem looks like it's 22. There is one type of x. I can just solve for it. All right, so first I'm going to add 8 over. Then I'm going to divide by 2, and then I will square root both sides to get that x by itself. And as soon as you square root, you get a positive and negative, and then the square root of 49 is a nice 7, and here we have two answers. All right, let's see, 24 and 27 are also x squareds, but these both have more than one type of x. So first I gotta make sure it's equal to 0, so I'm gonna subtract the 21 over, and then I'm gonna look at a GCF, and I don't notice a number factoring out or an x factoring out. So I'm going to go straight to my x, and I need factors of -42 that make -11. And then you can run your factor program. My online calculator doesn't have the factor program, so I'm just typing in +42, and I notice that 3 with 14, -14 that is, will make my -11. So x's will not be enough. This only makes x squared. So I'm going to have to put that 2 in there. And then I'm going to make my face, my loops. And a 2x can make this -14x. So let me put that there. And that means the other loop can make the 3x. So 2x times what can make -14x? That's a -7. And then x with a +3 can make my 3x. All right, so set each factor equal to 0. So in this one, I'd subtract 3, and I would divide by 2. And I'm just going to leave it as the fraction. And on the other one, x minus 7 equal to 0, just add 7. And remember, I'm supposed to get two answers. There they are. So number 27, there is also more than one type of x. So I'm going to have to set everything equal to 0. So I'm going to move the 5x over. And now I'm going to look for a GCF. So this actually does have a GCF. I can't factor out a number, but I can factor out an x. So here goes the x. And I'm left with the 3x minus 5. And then that's it. I can't factor these anymore. So to get my two answers, I set this one equal to 0, this factor. Done. X is alone. If I set this one equal to 0, I add 5. And then I'll divide by 3, and I'll just leave it as a fraction. So again, I'm getting two answers. All right, any other squareds? Not right now. So let's go for some other problems. So on 19 and 21, there are both cubes. So when we did problem 19, we were in chapter 2, and we didn't know about imaginary answers. So here we go. I'm going to isolate x because there's one type of x, so I'm going to add 4 over to the left side, which gives me a negative 4 over here. And I have another fraction, so again, just to get rid of the fraction, I'm going to multiply by its reciprocal, because then these 2's cancel out, the 1's cancel out, the negatives cancel out. So I'll multiply this side by a negative 2, so that leaves me with a positive 8 over here. And now to get rid of the cubed, I will cube root both sides. And you got to remember, cube root on your calculator is the math button. The cubed root of 8 is 2. Okay? And then this just becomes x plus 3. And now to solve for x, I would subtract 3, and I get an answer of negative 1. So there are supposed to be 3 answers, but in this chapter, again, we didn't know about imaginary numbers. So in chapter 2, we only went for the answer the calculator would say. Now 21 is different, because by the time we got to problem 21, we had learned about the SOAP. So I take the cubed root of 8x cubed. I take the cubed root 125. And then we add parentheses close together and further apart. And in the first set of closer together, I just put their cube roots in there, 2x with 5. And then in the second set, I put these together, and these together. So 2x times 2x is 4x squared. 2x times 5 is 10x. And then 5 times 5 is 25. And then we remember SOAP. So SOAP is same, plus sign to start with, opposite, and always positive. And now we can solve for x. So here we set the x equal to 0, subtract the 5, divide by the 2, and we get negative 5 halves, which I'm going to leave as a fraction. On this one, we talked about you will always have to do the quadratic formula. So quadratic formula, I'm going to take x equals the opposite of b, plus or minus, I'm going to have a square root, and now I'm going to take b and square it, minus 4 with my a and my c, and then all of it's over 2 times a. All right, running out of room there, so I'm going to move over here. All right, so the 10, the plus or minus over 8, and then I go to my calculator and I just type in, let's see, and I get negative 300, which then I can run my factor program on 300, not negative 300, and realize I could break it into 100. That's supposed to be 100, not a very good 100. 100 with the 3. And so the 10, the plus or minus, the square root of 100 is 10. Square root of a negative number is I with the square root of 3 all over 8. Better answer. And then I go for my triangle. I can divide all of those by a 2. So when I'm done, the answer to 21, divide everything by 2, is this. So there's my final answer there.